So I'm going to try to walk you through a couple of these and let you finish the rest. So what we're trying to do is figure out the sample size. How big a sample do I need to take to stay within these margin of error, to stay within these tolerances, okay? So they're telling us this is a normal distribution. What do they say that? Assume it's normally distributed. They told us that this is the population standard deviation, so that allows me to use z-scores. Okay, let's see. It's telling me the mean is 8, but I don't need that for this problem. So what do we do? Well, I know a confidence interval formula when I know the population standard deviation looks like this. I've got the sample mean plus or minus some z-score that's defined by the level of confidence times the standard error for the for the sampling distribution, or that's also known as the standard deviation for the sampling distribution, is you take the standard deviation of the sample and divide it by the square root of the sample size. Okay, so what we're going to do is, now this part here of this is the margin of error. That's the plus or minus. Okay, it's the margin of error. And I don't know why I just wrote MER. Margin of error. That's good enough. So then what we're going to do is we want the margin of error to be equal to 0.1. So that's what I'm going to do. I'm going to say, okay, I want that margin of error, that right-hand side of that equation or that formula, to be equal to this. And what I'm going to do is substitute everything in, and then I'm going to solve for n. So I went out earlier and I found these z-scores for these level of confidence. And we're going to use these to solve this question. So let's substitute in what we know. So 0.1 equals, now let's see, for a 99% confidence interval, we're going to use 2.58. And we know the standard deviation for the population is 0.5 over the square root of n. That's what we're solving for. So we have to solve this equation. So I'm going to divide both sides of this equation by 2.58. Right? 58, sorry. And I'm going to calculate that on my calculator earlier. Okay, I'm going to pull that off so I don't lose it. And so that leaves me that number, 0.0388 around to, and that's over 1 equals 0.5 over the square root of n. So now I've got a proportion. I can find my cross products. So I'm going to cross multiply. I'm going to go 0.38 times the square root of n equals 0.5. And now it's just some pretty basic algebra. I'm just going to divide by the 0.0388. Ideally, I would just leave these numbers on my calculator so I don't have to worry about the rounding. Okay. So I'm going to do 0.5 divided by that answer. So 12.9. And then solve for n, I'll just square both sides. Oops, I'm sorry, just missed that one. I wanted to square, not take the square root. So it's 12.9 raised to the second. So I need a sample size of 167. I'll have to round up because I can't have 0.41 people. So sample size of 167 should keep the margin of error within 1/10 of a centimeter. Now, if we want to do the same thing at the same level of confidence, all that's different is we would come back up here and we would replace this with 2. And then it's the same process. You would divide by the z-score, find the cross products, divide 0.5 by that number that was be there, and then square it. Okay? And the only thing that changes as you change your level of confidence is you're going to be replacing, let me get a highlighter here, would replace the z-score with that other z-score. Okay, and then it's the same process. Okay, hope that helps you solve this problem.